Welcome to reading quiz number 3. This reading quiz is a short one. It's all about asymptotes, and particularly how asymptotes relate to limits at infinity. So let's do a quick little review of the term asymptote. Both of the limit types involving infinity are connected greatly with the idea of the asymptote, which comes from the Greek word for non-intersecting. Unfortunately, this is extremely misleading, and you may have some of those misconceptions yourself about what it means to actually be a horizontal asymptote or a vertical asymptote. As the outputs become unbounded, we get a vertical asymptote with the equation x is equal to a. In other words, f of x goes to infinity or f of x goes to negative infinity as x approaches either from the left or from the right. For a function, telling whether or not that function has a vertical asymptote is just a matter of seeing if that function has an infinite limit. Sometimes this requires you to know a little bit about the function. Sometimes you need to investigate using limits. So let's find an example here, example number 4 from the reading. Suppose f of x is equal to x squared minus 16x plus 55 over x squared minus 13x plus 40. Find all vertical asymptotes for f of x. Now, this is the sort of thing that you might look at in pre-calculus, and in order to find vertical asymptotes, if you remember, what we did was we factored our numerator and our denominator, saw what factors canceled, and if something didn't cancel in the denominator, it ended up being a vertical asymptote. This is the same idea here, except now we need to make sure that we justify our answer with limits. So using synthetic division to factor, or just using regular factoring techniques, we find that f of x is x minus 11 times x minus 5 over x minus 8 times x minus 5. Since we can cancel out the factor at x is equal to 5, we end up with a hole in the graph at x is equal to 5. And this relates to what we just did a couple of reading quizzes ago, where we can actually find a numerical limit. However, if we investigate limit as x goes to 8 from the right of f of x, we find that that limit is equal to negative infinity. The reason being the x minus 11 portion will produce a negative number other than 0, and the x minus 8 portion will produce a positive number close to 0. And from a previous reading quiz, we know that gives us a limit of negative infinity. Similarly, the limit as x goes to 8 from the left of f of x is equal to positive infinity. Both of those facts combined, and either of those by itself, would tell us that f of x has a vertical asymptote of x is equal to 8. Again, there's a hole in the graph at x is equal to 5, so that's not an asymptote. Horizontal asymptotes. As the inputs become unbounded in either direction, as x goes to infinity or negative infinity, we get a horizontal asymptote of y is equal to L. So this could mean either limit as x goes to 0, x goes to infinity of f of x is equal to L, or limit as x goes to negative infinity of f of x is equal to L. It is important that you check both limits at infinity in order to determine horizontal asymptotes. You could have two different horizontal asymptotes depending on which direction you go. If a more powerful function is on the bottom, as we looked at in the previous reading, a horizontal asymptote is y is equal to 0. If the more powerful function is on the top, there is no horizontal asymptote. And if the function types balance on the top and the bottom of our rational function, then we have a horizontal asymptote that has a particular numerical value other than 0. So example 2 from the reading demonstrates this. Find any horizontal asymptotes of f of x equals 1 plus x squared over 2 plus e to the x. We need to investigate two limits. The limit as x goes to infinity of 1 plus x squared over 2 plus e to the x. The dominant function here is the e to the x, which is a ninja from the previous reading, so that limit is equal to 0. Thus, f of x has a horizontal asymptote of y is equal to 0. How do we justify that? We say limit as x goes to infinity is equal to 0. Therefore, f of x has a horizontal asymptote of y is equal to 0. Are we done? No, we're not. We need to check the limit as x goes to negative infinity of 1 plus x squared over 2 plus e to the x. A simple inspection tells us that the numerator approaches positive infinity, but since limit as x goes to negative infinity of e to the x is equal to 0, which we talked about last reading quiz, the denominator approaches 2. So we got a situation where we got a number approaching infinity on the top and a numerical value on the bottom. Thus, the limit as x goes to negative infinity of f of x is equal to infinity, and we have no horizontal asymptote as we go to negative infinity. Overall, this function f of x has a horizontal asymptote of y is equal to 0, but just a single asymptote. Example 4 from the reading. Find any horizontal asymptotes of h of x is equal to 3 times absolute value of x minus 7 over x plus 8. Again, we need to check. Limit as x goes to infinity of 3 times absolute value of x minus 7 over x plus 8. As x goes to infinity, absolute value of x is the same as x. So limit as x goes to infinity of 3x minus 7 over x plus 8 is equal to 3. So y is equal to 3 is a horizontal asymptote. Checking the other side. Limit as x goes to negative infinity of 3 times absolute value of x minus 7 over a quantity x plus 8. As we go to negative infinity, absolute value of x goes to negative x, which is why we get a negative 3x right here. So we have limit as x goes to negative infinity, as x goes to infinity of negative 3x minus 7 over x plus 8 will be negative 3. So y is equal to negative 3 is a horizontal asymptote. Oftentimes, but certainly not always, square roots and absolute values will produce 2 horizontal asymptotes. Example 48 from our guided practice. The question asks us to find the horizontal asymptotes for the following function. Make sure to check the negative and positive sides of the graph. Use limits to explain your answer. Function being y is equal to 3 plus 2 e to the x over quantity e to the x minus 5. So we're going to investigate 2 limits. Limit as x goes to infinity of 3 plus 2 e to the x over e to the x minus 5 is 2. We've got ninjas of degree e. There are 2 of them on the top and 1 on the bottom. So y is equal to 2 is a horizontal asymptote as we go to infinity. Limit as x goes to negative infinity of 3 plus 2 e to the x over quantity e to the x minus 5 is negative 3/5 because as x goes to negative infinity, the e to the x on both the top and the bottom will go to 0. So we're just left with the 3 constant on the top and the negative 5 constant on the bottom. So this function has 2 horizontal asymptotes. Y is equal to 2 and y is equal to negative 3/5.